to establish that today. So we're very excited to have you, and we hope that you take away some nuggets of information that are helpful to you. Thanks, Kevin.
Yep, good, thank you. I'm CEO of Ectobox, and we are a company that is a partner, a certified partner with PTC around the ThingWorx and AR products, and we're also really excited to do this webinar. My objective with this webinar is to help you as manufacturers, and hopefully there's some service companies out there as well, to provide a purely educational conversation here. In this conversation, we're going to talk about what remote monitoring is, why it's a great place to start, and also how it's valuable. We'll also show you a few of the technical details so you know a bit about what's under the covers. No magic behind the curtain, it's real stuff, and just so you have an appreciation for it, if nothing else. And lastly, then I'll introduce an idea which I really like a lot about implementing remote monitoring solutions and other solutions like this so that you can set yourself up for a better future. And to do that, and here's the kicker, to do that within the context of ISA 95. We'll get into that more later. Also, as a reminder, at the end of the session, I'll also throw this out there. We've promised for anybody who signs up for this webinar that we'll send over a really good ebook around remote monitoring and data analysis, as in artificial intelligence, machine learning. I like that ebook a lot. I'm going to be sending it out to everybody, and also we'll provide a link to the recording for this webinar so that you can catch a couple parts again and whatnot. And for those who are not able to attend, I'll also be sharing it with them as well. Also, just a little one last piece of housekeeping. Based on the fact that I am keeping this webinar to 1/2 hour to make sure it fits into everybody's schedules, because everybody's so busy these days, we won't be able to provide the opportunity for Q&A. However, you're more than welcome to send emails, messages, or call either Michelle or I, or both, and we might reach out to you as well. And feel free to ask us questions. We'd love to learn more about what kind of challenges you have going on and how these kinds of solutions might help and whatnot. So with that, I'll get into it. Let's see. All right. So manufacturers. We're really talking about manufacturing here, and talking about manufacturers using IoT to make major improvements in their companies, where they're pulling data from machines and converting that data to valuable information. And with that data, a lot of companies are looking at spindle time versus production on CNC machines, or getting breakdowns of downtime by reason code and also duration or counts. Trends in their cycle times for production, OEE by machine and line, data around a whole plant or multiple plants, and multiple other things. And some companies are further down the road than others around this. Some are trying to figure out where to start. And if you're not really sure where to start, our recommendation. Look, I'm getting a message here that's telling me something, so I want to make sure that everybody can hear this. I apologize. Oh, boy. Hey, everybody, a little technical challenge, and that technical challenge is between my keyboard and my chair here. I didn't do what I should have done for starting this webinar off. So again, my apologies. Michelle, we're going to have to do that intro again. I'm just being really silly on this end. Just the simple little things get you sometimes. So again, Ectobox, we are an industrial intelligence solutions company, and we're a partner with PTC. And we are here to talk about remote monitoring, starting with downtime and improving your operational capabilities. Michelle with PTC, we're partnering with PTC on this webinar. So Michelle, would you mind again introducing yourself? And again, I apologize for everybody.
Hi, everyone. Thank you for joining. My name is Michelle Watson, and I work with PTC. I head up the IoT and AR initiatives for manufacturing companies in the West. And Kevin and I at Ectobox, we work together to help drive value with our customers and prospects that are looking to adopt things like remote monitoring and what we're talking about today, and just finding where there is a fit within your organization. So we're very excited to have everyone here. And Kevin, I'll throw it back to you.
Okay, great. Thank you again, Michelle. And last time I'll apologize to everybody for a little bit of confusion on my side here. If you're a golfer, let's call that my mulligan for the day. I think I'll use that one. So for this webinar, let's talk about remote monitoring. Manufacturers are using IoT to make major improvements in their companies and pulling data from machines, converting that data to valuable information. And when they do that, they're often looking at spindle time versus production, getting breakdowns of downtime by reason code and duration, trends in cycle times, OEE by the machine or by the line, data for a whole plant, multiple plants, lots of different things. And some companies are further down the road than others, and some are still trying to figure out where to start. And if that's the position you're in, our recommendation would be, let's start with a little bit of remote monitoring of the machines, and maybe even just start to look at downtime of the machines, because when you do that, you can pretty often find some money laying on the floor, so to speak. And we have a couple little examples around that. I'm going to talk more about remote monitoring, pulling the data from the machines, displaying that. But first of all, why would you even want to do this? You can monitor the equipment to improve uptime, prevent unplanned downtime. You can get real-time data to understand exactly what's going on immediately right now. You can lower maintenance and service costs. You can improve the quality of your products you're producing by monitoring the machines, the tools, wear, etc., and improve production from the equipment, as well as, again, lots of other things. Let's put all of this in context with a case study. This is a company, real situation. Names are being withheld to preserve the identity of the innocent. But as a company, they're about a $50 million manufacturer. They produce sheet metal components for the automotive industry. One plant, 3 shifts, really tightly scheduled because they have a lot of orders going on, and their presses are the critical machine in the process. Though they have a problem, they believe their production should be higher than it is right now, but they're not really sure why, and they don't really have any insights into it, and they believe the causes are some unknown causes with downtime. They might have a few inklings of what's going on, but not a lot of details. And they have very little data on hand. The data that they do have is entered manually into log sheets when it's entered by some users or operators. And they have an ERP system, however, they have no SCADA or MES, and so they have no data at all coming from their machines. And worst of all, they believe, and again, they're kind of guessing here, they believe that the impact is around $25,000 in production per day, and that's a decent amount of money. Well, how do you solve this? We generally apply a very simple business-oriented process to these kinds of situations to figure out what to do. Identify the problem that you have at hand, build a business case around it to figure out whether it's worthwhile solving, and $25,000 a day, that sounds like that's worthwhile to solve. And then to solve that business case, what information, what charts, what data analysis do you need in front of you? Then you go to the next step. What data do I need to generate that analysis, those charts, etc.? And once I understand what data I need, and hopefully you can limit the amount of data, let's not go crazy because you'll confuse yourself if nothing else. Once I understand what data I need, then let's start to look at the technology. And in this situation, they've obviously identified downtime as a possible cause for that situation. So breaking away from this situation just a little bit, what for you, I just want to ask you a question. Do you have a sense of what your downtime is? Are you getting that kind of data? And do you know what your downtime is worth for your machines or for a line? Some companies tell us they're collecting the data on paper, just like this case study here. And that's great because you're collecting the data. It's a great place to start. However, it could be an issue for a few reasons. Time, variety and volume, and accuracy. Around the issue of time, there are, well, what I'll cover here is what I think of as the early benefits. That data is entered on paper, hopefully by conscientious operators who are actually entering the data compared to the ones who aren't. Those sheets are collected by somebody in the office. It might take a couple of days to get the data entered into Excel, and then eventually it gets to the manager or the owner a week, maybe 2 weeks later. But with remote monitoring, there's no waiting. It's real time. You can see the machine and the operator is down right when it happens. And you can actually walk over and say, hey, what's going on? As opposed to, hey, Joe, do you remember what happened last week? No, I have no idea at all. I went to a wedding over the weekend and, just completely gone. I have no idea. Around the amount of data, what we could call the volume and variety, there's an issue there as well. Operators don't have much time to record much data, nor do maintenance staff. But with remote monitoring, it's not an issue. You're connected directly to the machine, and so you can get a lot of data. You have to be very careful about that, as I mentioned before. Pick only the data you really need to solve that certain situation. But it's all right there, and it's the amount of data, volume and variety. The number of fields or tags and the amount over time is not an issue at all. And lastly, accuracy. We're human. I'm human. I do data entry mistakes all the time, typing letters and emails and other things. And I'm sure that the office staff are probably doing that a little bit as well when they're entering the data from or around production and downtime, et cetera. But with remote monitoring, there are no errors by humans in entering and re-entering the data. It comes straight from the source. So with that, then, what does a solution look like? You're pulling the data real time. Here's a chart that you might see for a particular press. And you can see here over the last couple months, the die repair, there's a quality issue around that. And that has been pretty consistent overall compared to all the other situations that are going on. That's pretty compelling. It's hard evidence that you can then start to tackle. Let me also show you some other screens in ThingWorx about what the downtime might look like. So here's ThingWorx. ThingWorx is an industrial innovation platform that we work with, and again, we're partnered with PTC around this platform, certified developers, and we provide a lot of different solutions with the ThingWorx platform. This is a solution that was created for a company a few years ago, I believe, by PTC. They have then recycled this, so to speak, to use this as a really good demo product. Names, of course, have been changed to preserve the identity of the innocent, and so they've converted this to, let's call it a tractor manufacturer, and the name of the company is Acme, of course. You can see a lot of different views on the data, including maps of all your plants, some summary data on your plants. You can then dig down, depending on your roles. COO, plant managers, etc. You can start to dig down into the data for a specific plant and see what's going on. I'm having some technical issues here. It was working earlier today because I'm not connected with the data source, I think, in the way I should be. So with this kind of view of information, you can see OEE, efficiencies, trend lines, etc., and you can see it for the various plants. And then you can actually get into data about the lines of the plants as well. And you can even see the downtime by duration, downtime by occurrence. And in this situation, you can see the tire lifter and the frame placer. Both of those have been down quite a bit. And depending on the costs of downtime, it might be pretty significant. So these are some pretty good examples of the kinds of solutions we can build around downtime. And this is what remote monitoring would look like. Pareto charts, bar charts, trend lines for activity of the machine, et cetera. And that can give you that real-time data, all of the data that you need, and that data is going to be accurate as well. So applying that to this particular situation, then you can see how it would be possible to actually solve issues around those presses. But let's actually kick it up a notch. Let's add alerts and predictive to this. We've obviously got some good data coming for remote monitoring, but let's add alerts to it. You can set up certain conditions in an IoT platform like ThingWorx and trigger alerts when certain conditions are met. Some of those conditions we've seen are, a machine is offline for maybe 10 minutes, then throw an alert. Okay, got to go over and check out the machine, what's going on. Let's start to handle things, and let's provide some positive coaching to get things back in shape. Temperature rises above a certain level, or total remaining life is reached or reaches a certain point, then throw a notification. Then maintenance goes out and checks out what's going on, or at least maintenance then knows, hey, I got to look at some of the trend data, some of the details. Those alerts can be email, text, throw alerts up on a big screen TV on the plant wall, or we can even push messages out to other systems, other software systems like CMMS for maintenance, where they manage their work orders. We could push data in there to create a work order. And now at that point, your staff don't have to constantly watch the screens for changes. Rather, they can be notified of what's going on. Let's add predictive. That's another step we can add. When we're adding predictive capabilities, we're able to determine with a certain probability that a certain event might happen within a certain time frame, well ahead of time, whether it's hours or weeks, depending on the situation. You can then build that capability by pulling data from the machines, working with a solution provider like us to push the data into a machine model, build up some algorithms, which then provide you with that predictive capability. And we can use tools like the ThingWorx analyzer tool from PTC and combine those models with some alerts. And then at that point, you're really cooking with gas. You're starting to alert people about situations that are going to happen in time, and then you are lowering costs even more for maintenance situations. Things don't get so critical and catastrophic. Costs to repair a particular machine are less. You don't have to replace the machine. You're just doing small repairs well ahead of time. You're able to determine quality issues and start to get into things like SPC, et cetera. With all of that in mind, let's think about how this could be applied for the case study that we're talking about. You have the real-time monitoring that can drive efficiencies by as much as 20%. Real-time data, even without the other capabilities, can provide bumps in productivity, 5 to 8%. The alerts can alert your team of what's going on with those stamping machines, and then you could start to get predictive as well. And when you add these kinds of capabilities just with the remote monitoring as well as some of the other capabilities as well, the business case gets pretty compelling. And for that particular company, they were talking about remote monitoring providing a reduction in downtime of 45% and an increased production revenue of about $5 million. It's pretty compelling. Of course, your results are going to vary, but suffice it to say that the results can be really significant. Let me share just real quick a couple other short stories, and then we'll move on to the technology side and then building up for the future. There was a situation with a company where an operator ended up self-managing himself, and they effectively found some money on the floor for increasing production. There were 3 shifts in the machine shop. They generally thought the production was pretty good. Machines weren't yet connected, and they weren't pulling data yet. Management decided, hey, let's pull some data from the machines, but let's not let everybody know. Let's just see what's going on with the machines and the operators. Let's watch it for a little bit. And they noticed one of the machines in the first shift was slow in getting up to speed, up to the production levels that they expected and that they established publicly within the company. They then eventually put up a big TV screen to show the results of the machines and operators and what's going on. And then they looked back at it a little bit later and found that the productions for that particular machine were pretty quickly up to snuff, up to the production level that was expected compared to all of the other machines. And it turns out the operator for that one particular machine wasn't doing anything malicious. He was simply doing some setup and some machine cleaning that he thought was appropriate from the shift prior to him and also for the second shift. But after the TV screen went up, he actually saw what was happening. He realized his priorities were out of whack. And so then he started to self-manage and make adjustments to his priorities. And I think there might have been a little bit of light coaching as well from the shop supervisors. And then they were able to see uh, that what was previously over 3 shifts, a 10% decrease in production, get back up there to good production, and everything was good. I mean, it was kind of crazy the kinds of situations that they found. Another situation, a project that we worked on recently, which we finished with a big press, not this company I was talking about, but another customer had problems identifying when they needed to perform maintenance around the press. And the press is really big and experiences extreme levels of strain in certain areas. And it becomes a big maintenance issue, and especially a big downtime issue as well. If the issues are left unaddressed, then downtime is extraordinarily expensive and disruptive. So we worked with the customer's team to set up some strain gauges around the press and monitor the data. And we also set up ThingWorx to have a calculation in it to estimate the remaining life based on usage and level of strain experienced by the components of the machine. And at this point, the customer is now able to see well ahead of time when maintenance should be performed based on usage and actual status of the components in the press, and it's preventing significant downtime that they otherwise would have, which was, again, really disruptive and very, very expensive. So there's a lot of value in using remote monitoring solutions. 10% reductions in production can be eliminated. You can find money laying on the floor. In other situations, get utilization, which people will often think, well, I think my utilization is 80%, but then you actually find out it's somewhere between 30 and 50%. It's pretty crazy. It's a lot of situations that I've already talked about where you have value in these situations. So a real quick brief over the behind-the-scenes technology. This is a basic architecture of some of the solutions, and again, something similar for a press. You have the press, a PLC, operators doing some data entry for downtime reasons. The data goes to a local gateway device. We're using Kepware Server EX for the solution. There might be a Wi-Fi router if things aren't routed, if things aren't wired. And then we might be pushing the data to a cloud solution where ThingWorx is hosted. ThingWorx could be hosted on-prem as well, just depends on the situation. So given this kind of architecture, let's talk about some of the data. So again, as we talked about, the idea for solving a particular problem is to start at the top, identify what the problem is, and then from there, identify what the business case is, the information you need to solve that business case, what's the data you need to generate that information, and then let's get in the technology. But when we implement, we're going the other way. We're going back up. We start with some planning, and then we start to build up the stack. And so we start with the PLC and Kepware and the gateway, build in some pieces into ThingWorx, a little more Kepware work, and then we start to go up the stack even more. ThingWorx, create the screens, tablet, ERP, and then extend ThingWorx solutions even more. Just real quick for some of these things, once you start off with a PLC, you want to grab the technical documentation and find out the device addresses, where the addresses are in memory for the data that PLC will be able to provide. And you can see some sample screens for that. We then will map that data in an Excel file. This is the planning part. This is where we like to plan things out and be thorough with our solutions so that we can make sure that the solutions are good, solid, and stable. So we use an Excel file to display those tags, those registers from the PLC, and plan where those are going to land as far as tags for Kepware. Then we get out Kepware, we install Kepware, we set it up, we connect to the network card of the PLC, we define what PLC it is with the data protocol, maybe it's Modbus, maybe it's something else. And then we start to make other configurations in Kepware to get the solution moving forward. The connectivity to machines will vary. Some processes will be like this, where we have to get into some of these details. Other situations, some machines are much easier to set up. and connect with. And there are other tools that we use to do that, which I'm not going to get into here for the sake of time. But suffice it to say, these are some of the basic details that are going on in the background so you can understand what's happening. Then at that, in ThingWorks, we are setting up an industrial connection, creating a thing, T-H-I-N-G, which is essentially the start of a digital twin to represent the machine and its data. And then we bind the thing in ThingWorks, this digital twin, to the industrial connection that we've established. And then we start to connect Kepware to ThingWorks with IP addresses and all kinds of other things. And then at that point, we start to build mashups in ThingWorks. We'll also use a web application, oftentimes, especially around downtime reasons, so that we can capture those downtime reasons from the operator. Because there are downtime reasons that will occur that the machine is not particularly aware of, and the operator needs to provide some context around that. And we'll also do ERP integrations. There's a variety of ways to do it: APIs, file exchange services, going directly to the database, but we can provide those integrations. And then once we have that data from the ERP system, if appropriate, to provide operator information, customer information, job and part number information, labor information, that data provides some extra value, a lot of extra value to the data we have, so that we can understand more than just, hey, the spindle is running. Oh, the spindle is not running. Well, what customer is that for? What part are we running? Who is it? What machine is it on? And what shift are they in? And then we can start to slice and dice the information in a lot of different ways. So that, I hope, will provide you a good context for how we build out some of those solutions, some of the technical details. With that said, then let's get to our last topic here for the remaining minutes that we have for this webinar. Let's start to establish some first steps to ultimately achieve operational excellence. So just stepping back to what we've talked about before for remote monitoring and downtime. We've solved a single problem. Great. Now let's start to think about the future. We can do this as a single project, and then if we have another problem in the company, we can create another solution, remote monitoring, pull some other data into a ThingWorks industrial innovation platform and solve that problem, then solve that problem. And that works really well. But if you're really looking to find a platform that take you well into the future and to help you achieve operational excellence, you could look at those solutions as maybe just point-to-point solutions. And they're not being built within the larger context of the success of the company. So let's start to solve the problems of the future as well as the current challenges you have. Let's start to look at these one-off solutions as pieces of a puzzle that you can build over time. Let's start to think about how we can kill two birds, or actually multiple birds, with one stone. And the way you can do that is by using standards. Without the standards, you're going to have point-to-point solutions that go all over the place, and you'll have a lot of confusion. I mean, companies will ask us, hey, can you connect the solution to the ERP solution? Yes, absolutely. Happy to do it, and it's certainly technically possible. But does it make sense in this situation? And if it does, and very often it does, maybe let's start to think about putting that within, again, the context of a future, larger solution. We don't have to change the world. We don't have to get into crazy over-planning right now. But let's just put a little extra thought into it, and let's provide that foundation now for the future. The way we can do that, though, is by using standards. We can use the ISA 95 ideas and goals and architecture, et cetera, to provide those kind of standards. The ISA 95 standards will ensure, this is actually where ISA 95 really focuses, is to ensure that all moving parts, the people, the processes, the technology, are orchestrated well together and moving in the right direction. One of the actual goals of ISA 95 stated is that it will establish a framework for the manufacturing apps to enable the business and the plant operations, sometimes thought of as two separate things, will enable the business and the plant operations to work better together to enable operational flexibility and production capability. In other words, It's going to help everybody, the people, process, the technology, to work better together over time. Because often what's happening is this middle layer here, this middle layer, level 3, is missing. There's a disconnect, and often that disconnect is filled by paper and Excel files. A lot of companies, 80% of the companies, have little or no connection with real-time data, decision quality data, real-time data. And that gap, again, filled with paper and Excel, we're running into the same kinds of problems we had before. Really old data, late data, inaccurate data, poor data, not enough volume and variety. So with that in mind, then, let's start to create these real-time remote monitoring solutions and get a variety of, and then we're able to build over time the various functions and activities that are defined within the within ISA 95 to then provide some structure for the solutions. This gap that I was talking about before on the previous screen is addressed by the Manufacturing Operations Model Management System. This MOM, M-O-M, Manufacturing Operations Management Activity Model in ISA 95 defines those specific functional areas that are typical for manufacturing. And it then defines for us the architecture with which we can build. But the really interesting thing is that we don't have to replace all the software we have. This is much like we talk about with ThingWorx itself. It's a wrap and extend solution. It's not a rip and replace. It's a wrap and extend solution. So let's use these tools, ThingWorx and other tools within the ThingWorx suite, and a couple other tools that we use on a day-to-day basis to build this architecture. And the way you do it with these remote monitoring solutions is you pick one of these areas. Pick one of these areas that you want to get. Let's get some data collection about the machines that you're working with, and then put one solution in, but put it in within the context of this architecture. And then you find another problem to solve. Put it in the context of this. And again, it doesn't take that much extra planning. But then you're able to, at the same time, start to plan over time how to actually get a much more solid solution in place. A lot of people will often ask us, hey, can I use our BI tools for this? Well, BI tools aren't really sufficient because there's a lot of business logic you need to build in. And BI tools are simply analyzing data and displaying data. There's not a lot going behind the scenes. Same kind of question comes up about, say, the SCADA systems. And there are a couple of reasons why SCADA systems don't always work for this. They might. I know there are people on this call that know SCADA systems inside and out. They might work, but the SCADA systems lack, at least the older ones that are built on older technology, lack the visualization capabilities, store and creation of business rules, data integration capabilities, and also within the ISA 95 system hierarchy structure, SCADAs usually aren't built to handle and work with the type of data that the business systems need. And so there's a certain space within which they work really well, but they don't go up that stack very well. So this is a huge topic, and I had to skip over a couple ideas because of my snafu at the beginning. I think this is a really important topic to make note of because manufacturers are going to need to think about these kinds of things if they really do want to take their companies well into the future, to compete, to get better, to produce more with what they have now, et cetera, to get all of those solutions to talk with one another. And so I'll be presenting some more information about this in future webinars, and I invite you to provide us feedback on this topic and whether this is interesting to you, what aspects of it you think are really interesting, and whether you think it's important. So in summary, keep in mind that remote monitoring is a really good entry point for any kind of solution around making data valuable for those machines that you have and solving particular business problems and driving value to your business. And it can provide direct improvements in efficiencies and utilization through real-time, accurate data, and also using alerts and even getting to the point of using predictive capabilities. And also, please consider this idea of the industrial Internet of Things solutions like ThingWorx and other platforms to not implement them as single point-to-point solutions, but maybe think about laying the foundation for the future and putting them within the context of the architecture of the ISA 95 MOM activity model. And you might have some pretty interesting levels of success within the future. Again, if any of this is interesting to you, if you have some questions, please reach out to Michelle or I. We'd be happy to have a short chat with you about what your challenges are. If you have any questions, happy to talk with you about those. And as promised, we'll send out an ebook on the remote monitoring solution, and also we'll provide a recording of this call, this webinar. Michelle, any final thoughts you want to provide before we wrap it up here?
Just thank you everyone for joining us today. Like Kevin mentioned, we welcome any questions, and we'll be sure to follow up with everybody. And thank you for attending. And there's also a handout. If anyone didn't see it, feel free to download that. It's in the handout section of the webinar.
And I'll also be proactively emailing out to everybody as well. Happy
Oh,
to do that.
perfect.
Great. Okay, Michelle, thanks so much for helping with this webinar and everything else. And everybody, thank you so much for attending. Appreciate your time, and have a good week.
Bye, everyone.